Welcome back, ladies and gentlemen. Today we're going to talk about dividing polynomials. And in order to do that, we are going to refresh our brains on how to long divide. And we're going to take 76,950 divided by 18. But since I told you I didn't really want you using a calculator, what I'm going to do is I'm going to give you all of the factors of 18. So we have 18, we have 36. We have 54, 72, 90, 108, and 126. So you're going to want to jot those down also on your notes. So when I do long division, come on, computer. I'm going to move these guys down here. I take the number that I am dividing, or the bigger guy on top. So in this case, the 76,950. I'm going to put it under the division sign. I really wanted to write a 6 or a 9 for some reason instead of a 6. Did it again. And then the number that I divide by, in this case, the 18 will go on the outside. So then I ask myself, how many times can 18 go into 7? 18 doesn't go into 7, so that's a big old goose egg. I need to move my video. And then I ask myself, okay, so how many times can 18 go into 76? Well, I want the biggest one. So I see 18, 36, 54, 72, 90. Okay, 72. So 1, 2. Why isn't my mouse showing up? There we go. Sorry. I was trying to make sure you could see my mouse. So 1, 2, 3, 4. So 18 times 4 is 72. So I'm going to put a 4 up there. Then I take this multiplication and I write it down below. And then I'm going to go ahead and subtract. 76 minus 72 is 4. And then I ask myself, okay, how many times can 18 go into 4? Well, 18 can't go into 4. So because of that, I have to bring down the next number, which is 9. So how many times can 18 go into 49? Let's take a look. 1, 2, can't go in 3, so only twice. So 2 times 18 is 36. And we're going to have to scroll down a smidgen. So I'm going to go ahead and do that subtraction. 49 minus 36. Well, 9 minus 6 is 3. 4 minus 3 is 1. So I have 13. Well, let's see. And how many times can 18 go into 13? 18 can't go into 13. So because, again, I can't multiply into this one, the number I got as the subtraction, the difference, I bring the next number down. Oops, I put it in the wrong spot. No wonder that looked weird. So how many times can 18 go into 135? 1, 2, 3, 4, 5, 6, 7. 7 times. 7 times 18 is 126. We're going to go ahead and do that subtraction again. We are left with 9. And I notice I still have one more number. 18 cannot go into 9, so I bring that 0 down. How many times can 18 go into 90? 1, 2, 3, 4, 5 times. And then 90 minus 90 is 0, so we end up dividing fully out. So my answer is what is 76,980 divided, 950 divided by 18. 4,275. Woo! Just long divided. Now we're going to do basically the same thing with polynomials. So we're going to start by taking the bigger guy, or whatever is being divided by. We're going to put him under the division sign. If you can hear that, that's my cat playing with the blinds. On the outside, I'm still going to go ahead and put what's being divided by. So in this case, that, let's switch to a lighter blue. The x minus 2. So I asked myself, what could 18 go into 7? And that couldn't go, so I had to go to the next term. So what times x gives me 6x cubed? Well, it's not going to be another cube term, because I have to get to cube. Cube times one more doesn't get me cube, it gets me to a fourth. So I'm going to have nothing getting me into the cubic terms. But I know that 6 times 1, because there's an invisible, let's not highlight things. 6 times 1 will give me 1, will give me 6, right? And I need that 6, so I'm going to write a 6 up top. Not where I'm going to put you. X squared. I'm going to go ahead and do that multiplication. So 6x squared times x, 6x cubed. 6x squared times negative 2, because I've got 2 pieces now. Just got to multiply into both. Is negative 12x squared. And just like as I did before, I'm going to go ahead and subtract those. They're gone. Because I switched the first sign, I also have to switch the second one. So this now turns into a plus. So negative 19 plus 12 is negative 7. And again, I have 2 terms I'm dividing by, so I need 2 terms. So I bring down the next one. Okay, I need to multiply to 7x squared. Well, I have an x already, so I need at least a negative 7. And another x, because I need x squared, and I only have 1. So negative 7x times x is negative 7x squared. Negative 7x times negative 2 is 14. I have to do my subtraction, so essentially it flips all the signs. So this turns into a positive. Still too much. I just want to erase that. I don't want to erase all of that. Okay, it won't let me erase that for some reason, so we're just going to make this a nice large line and say you're actually subtracting. So negative 7x squared plus 7x squared, they cancel out. 16 minus 14 gives me 2. Again, I have 2 terms I'm dividing by, so I need to make sure I bring down that last term. So what times x will get me to 2x? Well, I already have the x, so I need just 2. 2 times x is 2x. 2 times negative 2 is negative 4. Gonna get my other color, and I'm gonna flip all my signs. 2x minus 2x goes 0. Negative 4 plus 4 goes to 0. So this polynomial divided out evenly. So my final answer, just like my final answer last time, was whatever was left on top. Oh, we're going to go with green. So my answer is 6x squared minus 7x plus, wow, it's rough. Next one. Again, we're going to identify what's going to be divided by. So the guy that's a little bit bigger is going to go underneath. So x squared plus 3x plus 5. It's going to be divided by x plus 1. Okay, the only way to get to the x squared here is x times x, so I need another x. X times x gives me x squared. X times 1 gives me 1x. Okay, different color, and flip all my signs. X squared minus x squared cancels. 3 minus 1 gives me 2. Again, I'm dividing by 2 terms, so I need the second one to come down. I need to multiply to 2x, and I have an x, so all I'm missing is a factor of 2. So 2 times x is 2x, 2 times 1 is 2. Flip all my signs. 2 minus 2 goes to 0, 5 minus 2 is 3. But now I've used all my x's. I'm at my constant spot. So this means that we have a remainder. A remainder is something that's left over. For example, this is called an aside. An aside is something that helps us explain something else in a simpler term. So say I was taking 9 divided by 2. 9 divided by 2, well, 2 goes into 9 4 different times, gives me 8. I'm left with 1. I can't keep dividing. So my answer is 4 and 1 over 2. The 1 is how much is left over. The 2 is what I originally divided by. So my final answer for this problem is x plus 2 plus the remainder of 3 divided by what I originally divided by. Next one. I'm going to go ahead and start by identifying what I'm dividing by again. But if you notice, I don't have certain pieces. What I mean by that is, I go back especially to that first one because it was a bit of a longer one. I have a cubic term, I have a squared term, I have a linear term, and I have a constant. So I'm descending in terms of my highest degree. 3, 2, 1, nothing. My second one, I have a squared term, a linear term, and a constant. So again, I'm descending. 2, 1, nothing. However, in this problem, I have a cubic term and a constant term. So I'm missing that stuff in the middle. And I can't just pretend it doesn't exist. I need to show that it does exist, and we're going to show it as zeros. It's just like when I write the number 4,000. Even though 4 is the only actual number that's taken up in the thousand spot, the rest of the missing things, or the non-existent part, is taken with zeros or replaced with zeros. So when I write my dividing part, I have my cubic term, I have 0 squareds, I have 0 linears, and I have -1 constants. So I'm just going to stick a 0 attached to the degree I'm missing. Just like I stick zeros in where they go for like 4,000 or 100,000 or 10,000. I'm indicating that we have more than just what I see, and we're replacing that missing stuff for the things that we don't see with zeros. Now we're going to go back like normal and divide by x minus 1. So what multiplies to x cubed? X times what? I'm sorry, multiplies to x cubed. I need an x squared. And if I didn't write that initial 0 x squared here, I wouldn't have thought of that step. I would have tried taking and just putting it over the 1, like, I don't know. Right, so x squared times x is x cubed. X squared times -1 is -1x squared. Get another color and flip all of my signs. X cubed minus x cubed goes 0. 0 plus 1 is 1. And again, I have two terms, so technically I still bring it down. I need to get to x squared, and I have x, so I need a factor of x again. X times x is x squared. X times -1 is -1x. I'm going to switch colors, and I'm going to flip all of my signs. X squared minus x squared is 0. 0 plus 1 is 1. Again, I have two terms, so I need to bring down my last one. What multiplies to x that would give me x? Well, I already have x, so x times what gives me x? The only thing it could be is 1. So 1 times x is x. 1 times -1 is -1. Get your different color, flip all your signs, and we're going off to 0 again. So my answer for this problem is x squared plus x plus 1. Last one. Now, if you notice, the big guy that we typically divide by, so it's just backwards, right? It starts with my constant, then it's got my linear, then it's got my quadratic, then it's got my cubic, and then it's got my quartic. So instead of descending, it's ascending. But we don't want to do ascending, we want to do descending, we want to go backwards. So all I'm going to do is I'm going to rewrite everything. Same thing by what I'm dividing by. It's just flipped, but it's also got 3 terms. So first, again, we're going to identify what we divide by, which is the bigger guy, and we're going to write it correctly, so in descending order. So 2x to the 4th plus 4x cubed minus 5x squared plus 3x minus 2. And again, we want to make sure that we bring all signs associated with our numbers with it. So if I see a negative, I need to stick a negative with the sign it's attached, which the number it's attached to. And then same idea, here's what I'm dividing by. I need to go in descending order. So x squared plus 2x minus 3. So what times x squared will give me 2x to the 4th? Well, I need at least a factor of 2. That I can see is evident. And I need 2 more, because if I only put 1, that would give me the cube, and that's not high enough. So I need a squared. So I need 2x squared. So 2x squared times x squared is 2x to the 4th. 2x squared times 2x is 4x cubed. 2x squared times -3 is -6x squared. And the only difference about dividing by 3 terms is then now I'll have 3 terms when I rewrite it. Same process. I'm going to take a different color and I'm going to switch all of my signs. So 2 minus 2 goes to 0, 4 minus 4 goes to 0, and then -5 plus 6 is just a solid 1, so I have x squared. And again, I have 3 that I'm dividing by, so I need to bring down the next two guys. All right, x squared times what gives me x squared? 1. So did I end up having anything in the x spot since 1's just a constant? Nope. So just don't forget to write plus 0 so you don't forget that we're going straight to the constant spot. Okay. Let's go ahead and multiply. So 1 times x squared is x squared. 1 times 2x is 2x. And 1 times -3 is -3. Get a handy dandy color to flip all of your signs. X squared minus x squared cancels out. 3 minus 2 is 1, so x, and negative 2 plus 3 is 1, so plus 1. Again, I got to that constant spot. I shouldn't have anything left over, and if I do, it just means I have a remainder. And we already talked about how to write a remainder. So my answer is 2x squared. I don't have to write plus 0x. I put it here as a placeholder, just like when I do long division and I get zeros. So then plus 1 plus the guys left over divided by what I divided by. All I got. Have a great day, guys.